Hey, welcome to your favorite intermediate algebra class. Today we're going to talk about piecewise functions. We're going to represent some piecewise functions. We're going to evaluate them. We're going to graph them. We're going to write equations for them. So a piecewise function, you guys, if you're looking at this, that right there, that's a piecewise function. You notice that it's represented by a combination of equations, which each corresponds to a part of the domain there. Okay, so let's just start out evaluating f of x for part A. Let's do this part A when x equals -3. So what would f of, we're going to let x be -3, what would that be? So you're looking at this and you're like, well, which one do I use? Do I use the x minus 4 or do I use the, let me write this real quick. Do I use the 3x minus 1 equation? Well, that x value tells you which one to use. So you say, well, if x is -3, is -3 less than -1, or is -3 greater than or equal to -1? You say, well, of course, -3 is less than -1, so that's the equation I'm going to use. So I'm going to use this one because -3 is less than -1, so I have to look at the domain there. So we got -3 minus 4, so I got -7. So I have the point -3, -7 on my graph, okay? Let's do the next one, part B. Well, how about when x is -1? What would that be? F of -3. Whoops, I'm sorry, f of -1. F of -1. So this time I say, well, is -1 less than -1? Or is -1 greater than or equal to? Greater than or equal to -1. You say, well, of course, it's greater than or equal to, so I got to use that 3x minus 1 equation. So I'm using this one, 3x minus 1. I'm plugging the -1 in. So I got -3 minus 1, so -4. So f of -1 is -4. Okay. All right, let's graph a piecewise function now. We're going to set it up using the domains as well. So let's do this first part where y equals -x plus 1. Now you notice your domain on that says, give myself a little more room here, um, that only when x is less than 0. So if it's strictly less than 0, that means I cannot include that point on the graph. So I'm going to leave it open right there. But then I'm going to pick a bunch of x values that are less than 0. Less than 0. And I'm just going to plug them in until I get a few points. And you know that y equals -x plus 1 is a line, right? That's a linear equation. Y equals mx plus b. So let's take a look at plugging in a few of these points, okay? So if f of x equals -x plus 1, f of 0 would be 1. So y equals 1 when x is 1. Oops, that's a crooked. All right, now let's do -1. So -x plus 1, so we got 1 plus 1, 2. 2, we got the point -1, 2 on the graph. Now we plug in -2. So we got -x, so that ends up being 3. And we got -3, plug that in, that's going to spit out 4. So on our graph here, we got 0, 1, but it's open. I cannot include that point there. And then -1, 2, I include that point, -2, 3, -3, 4, and so on. So you can see that this line goes to the left, and you're like, oh yeah, I knew that because -x plus 1 has a y-intercept of 1, and then it goes down 1, right 1, you know, so it has a y-intercept of 1, down 1, right 1, down 1, right 1. So we knew that the whole line looked like this, but the problem is you're restricted. X is only less than 0. So you have to erase the other stuff there, if you will. Anything to the left of 0. That's why we open that hole up. Anything to the left of 0, less than 0 there. Okay? All right, now we got this other one, y equals 2x plus 1. Let me erase this part here. Okay. So f of x equals 2x plus 1, but only when x is greater than or equal to 0. So this time, I'm going to start at 0, but I can keep this closed now because I can include 0 or equal to 0, and then I'm going to pick x values bigger than that, greater than or equal to 0. Okay, and I'm going to plug them in one by one. So let's start with f of 0. 2 times 0 plus 1 is 1. Now we go f of 1. 2 times 1 plus 1, so we got 3. F of 2, 2x plus 1, so we got 5. And then finally f of 3, 2 times 3 plus 1, 6 plus 1, 7. Okay, so 0, comma 1 is filled in, and you notice, oh, now the function has been defined. If you define it at that point, since they hit at the same point, you fill that in right there. Okay, sometimes it'll be defined at like a different spot, like maybe it'd be up here, so you would have left that open. Okay, but it's defined right there, so fill it in. 1 comma 3, because 2 comma 5, 3 comma 7, and so on. So there's our piecewise defined functions. So let's say been defined by 2 or more equations, specific domains. Okay, let's do another one here. F of x equals x plus 3. So let's do this one, x plus 6, only when x is less than or equal to negative 3. So I'm going to start with negative 3, and this is going to be closed or equal to, and then I'm going to pick values less than or equal to. I'm going to plug them in one by one. Okay, so you got negative 3, f of negative 3 plus 6, you got 3. Then you plug the negative 4 in, negative 4 plus 6, so you got 2. Negative 5 plus 6, 1. Negative 6 plus 6, 0. Put those on the graph. Negative 3, 3. Negative 4, 2. Negative 5, 1. Negative 6, 0. And you're like, oh, okay, it takes off from right there, because x is less than or equal to negative 3, and moves on. Okay, now let's do the negative 2/3 x minus 3. So f of x, negative 2/3 x minus 3. Now this time we are greater than negative 3. Greater than negative 3, so we're open right there. Greater than negative 3, strictly greater than. So the next greater x value is negative 2, negative 1, 0. Pick a few nice points, if you will. So let's plug in negative 3. Negative 2/3 times negative 3. Of course, that's going to give us 6 over 3, which is 2. Negative 1. Okay. And then we go to negative 2. So, well, let me put that point on there. Negative 3, comma, negative 1. Okay. Right there. You can plug in negative 2 and negative 1 and 0. You know, the next one I'm going to plug in is actually 0, because I know it clears it out right there. 0, negative 2/3 times 0, 0. 0 minus 3, of course, negative 3. 0, comma, negative 3. Okay? So I know it's going to hit that point, and I could plug in those other points as well. You also notice that your slope is negative 2/3, right? So I'm going to go down to right 3 from a point that I have. Here's that first point that I know is on there, down to right 3. So you can also do that as long as you know that it is greater than that negative 3. So it's only that part of that line right there. Okay. Greater than negative 3. Oh, I forgot to open that. I'm sorry. Strictly greater than negative 3. Okay. There we go. All right. How about a step function here? Now you know that f of x is a nickname for y. So if you have y equal negative 1, if you're looking at that, you're like, well, I know y equals negative 1 looks like this, right? It's that horizontal line, y equal negative 1. Now, the problem is it's been restricted here. You see that? You're between negative 3 and negative 1, and you notice it's open on an x value of -1, and you're open right there, and then you're closed at the -3 spot. Closed right there, and it's only those in between there. Everything else is undefined. And so you could also, if you wanted to, I mean, you could plug in some points and things like that, but that's probably the easiest way, is just to, with the horizontal, y equals a constant. Now the next one, y equals 1, y equals 1, and you're like, well, this is what y equals 1 looks like, right? But this time we're between -1, x value of -1, -1, I'm closed, right? I'm closed right there, and then I'm open at the less than 1 spot, open right there, and I'm defined all that in between as well. Okay, and so I would erase the rest of this line, y equals 1. Okay, last one, y equals 3. But I'm only in between, I'm only defined between less than 3 and greater than or equal to 1. So y equals 3 looks like this. There's our y equals 3. We are less than 3, greater than or equal to 1. Okay? Erase the rest of this thing. Okay, there's our step function. It's called a step function. It's a type of piecewise defined function. All right, let's write the equation to finish this off for this piecewise function shown. So you're given the graph. Now can you figure this thing out? Let's look at this first piece right here. You notice you're given 2 points. You notice it's a line, right? Straight line there. And you have 2 points. Well, what do you need to write an equation of a line? You need a point and you need a slope. So why don't we find the slope first, okay, for the green one. So number 1, what's the slope? You have the point -2, -2, 1, -1, right? So you could either plug it in or count it. Either way, y2 minus y1 over x2 minus x1. And you got 0, -2 plus 2. Whoops, I did that wrong. I'm sorry. y2 is -1. Sorry about that. y2 minus y1. So -1 plus 2. Let's get driving me nuts. Let me just erase that. -1 plus 2 is 1 over 1 plus 2, which is 3. And if you notice, you could also gone up 1, right 3, correct? Okay, so you have a slope of 1/3 on this thing. Now you have a point. You can use either of these, -2, -2, or you could have used the other one. And you got the slope. So I'm going to use point slope formula to write this equation. Y minus y1 is m, x minus x1. Okay, so you got y plus 2, 1/3 x plus the 2/3. Subtract 2, that's the same thing as 6/3. Y equals 1/3 x minus 4/3. Okay, that's the equation of the green line, but you notice it's been restricted, right? Where at? Let me go back up to this thing. Where is this thing restricted? Because it's obviously not this whole line, 1/3 x minus 4/3, is it? You say, well, it's been restricted. Let's drop my eraser there. You notice right here, that's the beginning point, right? And it's open. So where's it open at? An x value of 1, and then it goes to the left, so less than 0. So your equation is going to be this linear equation, 1/3 x minus 4/3 that we found, but only when it's less than an x value of 1 right there. Okay, it starts at an x value of 1, it does not include it, and then it shoots left. That line shoots left. Okay, let's do the other one here. Looks like you start out at an x value of 1, right? And you go to the right. So in fact, we can just say, we know it's going to be greater than or equal to 1 right there. And then let's write the equation of that line. We say, well, I know it has a slope. Let me go up 2, right 2. So slope is 2 over 2. So slope is up 2, positive 2, right 2. Slope is 1, and I have the point 1, 1. So that's step 1, find the slope. We have the point 1, 1, slope of 1, y minus y1 equals m, x minus x1. Distribute the 1. There you go, add that. Hey, look at that, y equals x. F of x equals x, right? Y equals x. There's the equation of that function. All right, make sure you guys bring your questions to class. See you soon.